Okay, so before we actually get into the lesson, I want you to brainstorm yourselves. Okay? What words do you know or key words do you know that mean to add? That mean to subtract? That mean to multiply? That mean to divide? Okay? What are I want you to write them in your little table under that operation sign. Okay? What words do you know that tell you that you're going to need to add? That tell you that you're going to need to subtract? That tell you you're going to need to multiply? And that tell you you're going to need to divide? Okay? Take a minute and write some down that you can remember. Okay, so let's talk about what words did you come up with that tell you you need to add? Levi. If you don't have these, I want you to write them down. Some, right? Some is the answer to an addition problem. What else? Isaiah? Altogether, that's a good one. Olivia? In all. Good. Lily?
How much more?
Nope. That is not multiplication.
Oh.
Okay, anything else? One I can think off the top of my head. What about total? It's one word. Altogether. It is. I'll leave it out. Okay, what about subtraction? So, how much more? Or how many more? Okay? The difference. Remember, that's your answer to a subtraction problem. Okay, anything else? Yep.
How much left?
How much more? How much left? Good. I'm going to add another one. What about decreased? Ooh, then what can we add to, if we have decreased in subtraction, what can we add to addition? Increased. Okay. What about multiplication? Kira? Times. Good. Anything else? What's the answer to a multiplication problem? Product. What's that little word that I tell you means to multiply? It's an itty bitty word. No, not two. What? What was that, Dylan? You went, you almost had it. Put up on the end of it. There you go. Right? Means to multiply. Anything else? You didn't even know you were answering a question, did you, Parsley?
No, I did not.
What about division?
I thought I was about to go to college.
Come on.
I don't know.
What? Divide.
Oh.
What's the answer to a division problem, then? Or if you have something else. Quotient. Good.
I'm gonna break my eyes dry. Wow.
Okay. Anything else?
No.
No. Won't work. Cam? I didn't hear you.
What about share?
Share. That's what I was getting to. Or share into equal groups, right? Okay. So we'll put equal groups. Good. Because if I'm going to bring M&Ms in and I'm going to share them with you all, I'm going to give you all an equal amount of M&Ms. I'm not going to give Hayden more than Durst.
Yeah.
Okay?
You can give me more.
No? Okay. You guys have anything else to add to this?
I'm the
No.
best.
No?
No.
Okay, so what I'm going to hand out to you right now are more words that mean each of these. Okay? I also passed around some glue sticks, so I want you to glue this into your math journal. Okay, so take a minute, glue this into your math journal. I'm going to pop. So, take a look at the list that you got glued in and compare it with the list that we came up to. Do you see some similar words or the same words or words that match or
Yes.
completely different words, right?
Yeah.
For adding, there was some, increase, altogether. We forgot the easiest one. Plus. Right?
Oh, yeah.
Okay, add, that's a good one. Subtracting, we had difference. We didn't even get minus. Okay, decrease. Guys, come on.
It wasn't.
Wait.
Remember that thing?
No, Here.
Okay. All right, multiplication. We had product. We had of. Look, distribute. Because when we use the distributive property, don't we multiply? Right? Twice or double. Okay? Look, the two different ways we can see to multiply. 7 times n or 7 times 6. Dividing, we had quotient. Okay, we had share. Cameron had that one. Okay? If you take half of something, we're going to divide by 2. So we're going to refer to these words when we're writing expressions. Now, this box right here, I need you to star. Okay, this is important. Okay, where it says reverse the order. Okay? So if you see the words than or from, that means you're going to have to flip-flop the numbers. Reverse the numbers. And we'll do an example like that so you know what I'm talking about. Okay? So, on your paper, we're going to do some examples. I'm going to give you a phrase. You're going to write the expression. Okay? So we're going to do quite a few examples on this. So I want you to copy these down. Okay? I need to make sure that this can see me. Here we go. Oh gosh, sorry. Okay, so your first example. If I have the words a number decreased by 5. Okay? A number decreased by 5. Copy this down, please. For your example, you're going to need to refer to. Okay? Whenever you see the word a number, okay? Whenever you see the words a number right here, a number, that's where you insert a variable. Because doesn't a variable stand for a number? We just don't know what that number is, okay? Sometimes they'll give you the variable, sometimes they won't. If they don't, just use a letter. It doesn't matter what letter it is, okay? A through Z, you pick. Levi, you can use L.
Yay.
Okay, so a number, so we're going to pick L. Here's our variable, okay? Decreased by. So decreased by means we're going to do what? Subtract, right? So L minus 5. So this is a number decreased by 5. Okay, here's your phrase. You wrote the expression. Okay, we're going to do another example.
Yay.
Okay. Let's do this. 3 more than a number K. Okay? 3 more than a number K. So let's break this down. Okay? 3, that's easy. That's the number 3. Okay? But look, more than. That tells us to do what? Add. Okay? But look, we have this word than. Okay? Look at your paper. The word than is under reverse the order, right? No, it doesn't. It's not reverse the operation. It's reverse the order. Because you guys would probably write 3 plus K, right? Right, but it's got to be, you got to flip-flop it because it's more than. It has that word than, so we got to flip-flop it. So the correct answer would be K plus 3. Okay? Now, with addition, it's not that important because what property tells us we can flip-flop our numbers when we add and we're still going to get the same answer? What property is that?
Addition.
Commutative, good. Okay? It really matters with subtraction. Okay? But when you're given a phrase, it's really important to just think about what it's saying. What is that phrase saying? 3 more than a number. Well, if I did 3 plus k, is this showing me 3 more than k?
Oh.
No, this one is showing me k more than 3, because I start with 3 and increase it by k. It has the word than, so you've got to flip-flop it. K plus 3. This one says 3 more than k. I start with k and I got to go 3 more. Does that make sense?
Yeah.
Okay, let's do another one. You guys got this copied down?
Yeah.
Okay, I'm going to erase it. Couple more, and then we'll start an activity.
Yeah.
Yay, Luke
Yay.
says. All right, let's do. Here's example 3. It's the product of a number and x. Okay? The product of a number and x. Product means what? Multiplication, right? Okay? So we know we're going to multiply. And in this case, I'm not going to write the operation down yet. I'm going to read the rest of it. Oh, wait. Not of a number and x. How about of a number and 10? I need to give you a number, right?
Yeah.
Duh.
I was like,
Gosh, Carolyn. So where it says a number, what are we going to put there? A variable. C? Okay. So the product of a number, C, and 10. Okay? So you could do C dot 10, because doesn't the dot mean to multiply? Okay? We could also write it as, wait, which numbers are coefficient here? The 10, because it's the number that's multiplied by the variable. So I could also write it like this, 10c, because this means 10 times c, or the product of a number, because I don't have that word than, right? So I don't have to reverse anything if I don't want to. Okay, or you could do c times 10 that way. Okay, or I could also separate it as c parentheses 10, because doesn't that mean to multiply? Yeah. Okay, what? That makes sense, guys? Okay. Let's see. There's one more example that I want to do, because you'll see it, and I don't want you to be confused by it. Okay, last example. Example number 4. Here it is. It is, oh dear, the sum of a number and 5 times 7. Whoa, Hellman. The sum of a number and 5 times 7.
oh, this is easy. Yeah.
Okay, so if we look at it, we have the sum. So what's that mean? Addition, right? Of a number, what's my variable? S, the sum of a number and 5. So that's S plus 5, right? The sum of a number and 5 times 7. Well, times tells us multiplication, right? So times 7. Is this right? No, because it's saying that we have to take the sum of a number and 5. We have to find that first and then times it by 7. So what do we need to add in here? Parentheses. Good. We've got to find the sum of a number and 5 first and then times it by 7. Does that make sense? Because if I don't have those parentheses, what operation would I do first? Multiplication, and it doesn't want me to do that. It wants me to find the sum first, so I got to add those parentheses in. Okay? Questions. You ready to do an activity? Both show. Okay. You're going to want to keep this out